Now I have chosen a few randomly chosen different countries just to give you an idea that the matching that I was talking about and the prediction are not just true of these particular countries, and I've very specifically chosen countries with very different geomorphological descriptions. Netherlands is a country which is below the sea level, as we all know. So that is a very different geographical structure compared to the other countries that we have considered. Prediction quality remains very accurate still. And the range of training and everything remains roughly the same. I have, my apologies, I have a slight different for Holland. The training here was between 10th February, start date was the same. 10th June is where we stop here. The reason we chose to stop at 10th June, did not bother to go up to 29th June, is simply because it is already in the remission and the prediction is already pretty good. You really need to go further up the training ladder if you are unsure about the quality of prediction. And this is just a little bit older. So we stopped at 10th June, and here we wanted to see how good a prediction we are actually making. Now, for that particular purpose, I invite you to have a look at the inset of the right panel, the death panel, on the daily statistics side. Look at the bell-shaped plot, and you will see the yellow region, which is the predictive region, is again bang on. So these are differentially chosen regions. So Netherlands was a country with low population numbers, moderate population numbers, below the sea level. New York State was a country. New York State was a country with a very high population, not a country, a region with a very high population density, deliberately chosen because America had very different infection regimes. For example, the one in Texas and the one in that particular region is New York is very different. So we have deliberately chosen them differently. Now we look at a Scandinavian country, sparse population, very high altitude, and very especially no lockdown, with the hope that they will automatically get a ring of immunity simply based on herd immunity. Well, they put the money a bit too much on that particular herd immunity aspect. And here you see the predictions are going topsy-turvy. The predictions are not as good as in the previous cases, simply because just due to lack of any protection, the numbers are raging like wildfire. And it is very, very difficult for a predictive model now to predict what's happening there and what would be happening there. So Sweden is sort of an exception. It is very difficult to predict because you do not have the same outliers as in the previous cases. South Korea, that's what I mean by Korea. Again, a decent case of prediction and a decent case of prediction both for infection as also for the mortality. Russia, nothing especially good or nothing especially bad. It's still the same level of comparison, very good. And we are looking at real numbers when we look at the numbers. Australia, a different part of the world. And please note that some of these countries suffered from late lockdown starts. Apart from Sweden, all countries have had their lockdowns, but some of them had late lockdowns. UK is a very good example of that. Spain, where it's almost contained now. And this is Hubei, the Chinese country where it all got started. I mean, the Chinese region where things got started in the first place. And I have here a sort of a comparison between Hubei and India. I will come back to the Indian statistics just a bit later. But this is just a prelude of what's to come here in terms of the Indian comparison. Look at the spiking numbers. I will come back to this in a second. Now here, I want to give you a comparative picture. The model is actually capable of predicting what might have happened if we had, for example, compared to the given lockdown led, an earlier lockdown or a later lockdown. Just to remind you, the official UK lockdown withdrawal date was 4th of July this month. So I did not know it. So at the time we were doing it, we preempted like 1st of July. So we took the 1st of each month as our predictive dates, not that far from the 1st of July. Look at the comparison. The left plot, and this is the infection comparison. So the left plot is what might have happened if 1st of May was chosen as the lockdown withdrawal date. The middle plot, the middle panel, suggests what might have happened if the 1st of June was chosen instead. And the last one is what might have happened if the 1st of July was chosen instead. Now, if you just compare, especially the one from the left with the one from the right, you will see that a lot more people would have died if the lockdown was withdrawn on the 1st of May compared to what is happening in the 1st of July. So it clearly tells, if you just compare the two plots, look at the red plots, red lines in the two plots, and you can clearly see both from the trained part of the data, that's the blue part, and the yellow part, which is the predictive part, there will be a lot more in terms of infected here. And I will show you the similar statistics now for the date, again for UK. So this is the UK mortality picture. So this is the 1st of May. What might have happened if lockdown was withdrawn on the 1st of May? Look at the second huge peak on and around the 120 mark. So you will see a huge second spike would have immediately followed. A lot more people would have died. Well, that spike is substantially lower if instead of 1st of May, it was 1st of June. The green line, the dotted green line in between is basically the suggested lockdown date, just for the comparison bit. And then we have the 1st of July, and you see we are fine now. And indeed, we are fine now. I'll show you real numbers later. But clearly, statistics, prediction, and preemption, they all agree with each other. Now, instead of the UK, I am taking a separate case of the lockdown impacts on Iran, another country which is suffering a lot. So this is another randomly chosen country. I will focus on the dead, as I said, that is my main focus. So that means the lower two panels. Daily infected in terms of the infected dead and the daily deaths. So that's the last right panel. As most of you would have seen and known that Iran has seen a huge late surge in second relapse in infection. Now, please compare the bottom two panels. You will see that while the infection rate is very high and the prediction that yellow regime is almost perfect with reality, the reported statistics of death seems to be far inferior. That means the reported number of deaths is far lower than what our model predicts. We have a certain case of misrepresentation of data. This is what our prediction tells me. You can challenge me on that. You can say, how do you know? It's very likely a case of your model failing to predict. I'm basing my observation on the fact that if my model practically manages to calculate all European and American countries almost perfectly, including Australia and other countries, it's unlikely that countries which have had issues regarding media suppression and media details will be the ones which are processing the right details. So this, according to me, is an example where official statistics and reality do not match with each other. Unfortunately, we will see something very similar with India again. So this is for France, and as you can see, the comparison is fair, the prediction is good, and both for infection as also for the daily infected, the blue region, the taming region, and then later the actual lockdown withdrawal date, there has been a very low second relapse. And in fact, with France, interestingly, I'm talking from the bottom two panels. Interestingly, the relapse number for the infection, which is the highest peak is at about infection 5,000, second relapse. The highest peak for the number of dead for infection is 600. Now that's a substantially high number, but still within the perfectly agreeable tolerance limit, and these are like one-offs. So again, the predictions are bang on. So now I'm looking at Brazil, another densely populated country with a huge surface area. And here, what we see is suggestive. What we see, and again, I'm focusing more on the bottom two panels, the daily statistics comparing infected against the dead. So the infected is not coming out with a terribly good prediction, as I warned you already, but the dead is. The death regime is bang on, spot on, and most unfortunately, they had a very huge late surge, but fortunately, they're past their peak. So Brazil, henceforth, is supposed to be within the strong containment regime. It suffered a lot, but it's now recuperating a lot faster as well. Poland never suffered a lot and recuperated already. So there was a second peak, and this is almost like a magic. We honestly did not expect to have such a clear and precise idea of the second peak emergence, which we are, and consistently so for all the different countries that we have actually considered. So, so this is for Portugal, the same quality of second peak match, both for infection as also for prediction. And I'm repeatedly saying my focus being on mortality. Infection statistics might not always be the most reliable in terms of the prediction part, because that's not what we are focusing on. We are biasing deliberately the mortality statistics. So these are the so-called R0s. So you will see the reproduction number varying against times. Initially, they were very high, and they were above the 1.06 number for a substantial length of time for approximately 2 months for all these different countries. And then they eventually went down to less than 1. That means within the containment regime. And this, again, recaps exactly what we have seen in the previous plots. I'm showing you plots for the different groups. The previous one was for class A. This is for class B, then we have class C and D. So the same sort of a statistics, please see and look that there are substantial differences in the individual natures. If you club Australia, Russia, and Vietnam as sort of similar looking statistics, the South Korean one is interesting because they enforced an extremely strict lockdown regimen, which could be clearly seen to have impacted a lot faster than Australia, Russia, or Vietnam, which apart from Vietnam, Australia and Russia suffered from late lockdowns a lot. So South Korea containment was a lot faster and a lot better, and practically and barely no relapse. So Spain and Hubei. Please note the Hubei statistics. I take it with a pinch of salt, as I mentioned about the Iranian statistics. It is apparently showing a negative initial R0 that is very unlikely to have happened. So this is dodgy. This has nothing to do with our calculation. This is just very likely dodgy statistics. So I won't claim any prediction based on that particular Hubei statistics, but for every other statistics, I will make that claim consistently. So. And these are certain other countries whose details I have just shown you. So the reproduction number varied with time. It changed a lot. It sharply decreased from an initial, a very high point, then a long plateau followed by a decrease, and at times a second plateau that was suggestive of the second peak. So all these countries did suffer from second peaks, and you could see that again from the R0 statistics. In a way, this is sort of a flashback onto what I have seen, looked at from a different prismatic overview. So these are the qualitative simulation results for Hubei. I deliberately kept them as a case of a spurious study, not for any particular claim or disclaim either way. So what is the success story? Well, a lot. Italy, prediction versus reality. So far, all I have showed you was real model plots. The plots are good. Plots are, I was claiming, bang on, but that will not tell you everything about the real numbers. Now, please do focus on the column that I call dead. That means the mortality statistics. And I'm repeatedly saying the infected statistics was deliberately made to suffer in terms of prediction, because we want it to be spot on with the dead. This, in a way, is the limitation of the present Bayesian MCMC scheme that we have followed. We have actually started working on a multi-layered Bayesian MCMC scheme that would get both statistics correct, but we have not got that yet. The dead one, the dead statistics, the mortality profile is the one that we are looking at. Look at the quality of prediction. While not 100% accurate, mostly it is spot on. This is for the Italian data. So if the data stands for real data, the model stands for the prediction made from the Bayesian MCMC together with the mathematical model that I have got. This is for Italy. And if you look at the deaths actually, all of them are predictions. So please note the result that I'm showing are 100% prediction, and the data training was stopped on the 29th of June. So I'm using data from the 29th of June and I'm predicting for the next effectively 2 weeks. I'll show you Indian prediction for the next, very unfortunately, 4 months with some green reality. Germany, again, extremely good statistics. So barring some real exceptions like 5th and 6th of July, And I have a very simple explanation why 5th and 6th of July is also the 12th of July. So for 12th, I don't know exactly, but 5th and 6th, there was a delay in the update, which probably impacted the result. So I'm not sure what is happening there. I suspect that the updates were not actually regular, because if you look before and after the 5th and 6th of July, the results are spot on. And now I come to the Indian chapter. So the Indian simulation, the qualitative parts, they're somewhat different, but not largely so. The somewhat difference lies in the fact that here your P group, that means the predisposed group, the healthy group, and the herd immunity protected group, they follow roughly parallel profiles: blue, purple, black, parallel profiles. This is a bit unlike of the previous statistics that we have seen. The rest is very similar. We do see an initial spike in terms of number of deaths that initially sort of saturates, or hopefully would saturate beyond time day number 250, where the day 0 is still the 22nd of January. So you can easily count yourself. 0 stands for 22nd of January, and my prediction is the saturation is happening, well, actually happening after about 275. But I will now show you the real numbers, where you can make your own comparison and draw your own conclusions. As before, the left panels are the cumulative the infected, and the right panels are the deaths. The outsets are always cumulative statistics, and the insets are daily statistics. So the left for infected, right for death. My focus again is on the death, where I get the blue part is the data training part, 22nd of January, 10th of February to the 29th of June. Everything beyond that is prediction, and we are getting extremely good prediction again. So this is the R0 for India, the profile of which is indicative that it still subsists consistently higher up until the 150th day. So that's not good. It's indicative, but please do not take that as your prime source of contention that the Indian situation beyond day number 150 will be in containment. As I will show you shortly, it is not that. So infection profile looks like this. This is the cumulative infected. I have separately chosen them out just to highlight the importance of the infection. And then the mortality. And then I'm comparing the Indian lockdown situation. So I have taken 3 artificial situations where the green dotted line is representing a probable lockdown withdrawal date. The left panel is the 31st of July. The middle panel is the 31st of August. The right panel is the 30th of September. And see, I'm actually challenging myself. I am predicting dates that things haven't happened yet, and I'm telling you, in a way, what I expect to happen. So this is like putting a very tall claim on myself, but I'm so very confident about the quality of the model that I actually dare to do that. So if we have a lockdown withdrawal in India on the 31st of July, what I see from my prediction is on and around day number 225, there will be a second peak that will slowly reduce and will be tamed after the 350th death. In terms of real numbers that I will show you later, I have got a CSV file for the day-by-day prediction going until the end of this year. So this is the first layer. If the withdrawal is in the 31st of July, so there are 2 things that I ask you to make a note of. There's a second relapse on and around the 225th day, and the death statistics then, the daily death statistics then, would hit a peak of about 700. Okay, so this is what I'm seeing from here. The daily death statistics would hit a peak of around 700. As opposed to that, if there was hypothetically a lockdown withdrawal, that means continuous lockdown until the 30th of August and withdrawal on the 31st, the second peak is much reduced, and the peak value, and there's no real peak value, the peak value is about 275. So that's about 1/3 of what we saw from the 31st July's withdrawal. If we went to the 30th September as the withdrawal date, the peak does not dramatically reduce. So the take-home message from this plot is, if it was possible to continue until the 30th of August, we would be a lot safer than what it would happen if the lockdown was withdrawn on the 31st of July. That's the reality. So the same things, but more from the infected statistics. And as I've told you before, the infected statistics is not my key focus, but nevertheless, I'm showing you basically to show that the infected and the mortality profiles here agree very much with each other. So the prediction, again, notwithstanding my own structure of the AI platform, it's still very positive and it's still very clear. So for the same 3 dates, 31st of July, 31st of August, 30th of September, instead of daily statistics, if we then focused on the cumulative statistics, you will see that I'm looking at, for example, 31st of July, the left panel. The black line shows the simulation prediction, and the red line shows what might have happened if, instead of, for example, a phased withdrawal that has already happened in India, if it was possible to continue lockdown until the 31st of July. So this is sort of a comparison that will tell you what might have happened then. So these are numbers. And look at the prediction quality. Now, I have shown you numbers, specific numbers for Germany and for Italy. And for both countries, you saw that for the date profile, for the number of deaths, data versus the model agreement was almost fantastically good most days. I have taken exactly the same days, that's my column number 1, but columns 4 and 5 are the data versus model for dead, and we look at the consistent underreporting beyond the 2nd of July, starting the 3rd of July, well, in fact, even before, the data are consistently underreported. So basically, if you look at the infection statistics here, you will see the number of reported infection is actually a lot higher than we are predicting, and notwithstanding that, the number of reported death is a lot lower than our prediction. The only conclusion that I can get out of that is, just like with Iran, this is a serious case of data being suppressed and being underreported. There is no second understanding or alternative that I can think about that. So please note, I'm not suggesting it on a state basis. I'm not talking about any political bias here. It's just a fact and not a political statement that I'm trying to make here. So it's a consistent underreporting of data. And now I will show you more. I'm going beyond that. I'm going beyond. Today is the 15th of July. And I have actually predicted the number of deaths to be at 655. If you look at the actual numbers reported, that is somewhere around the 450 mark, a lot lower than what it should. And 16th of July, so it continues unabated. The entire July going into the 12th of August, we have the number of death prediction more than 500 every day. After the 30th, starting the 13th of August, the number for the first time goes down below 500. It carries on like that all throughout August, September, and for the first time, our prediction model tells me that the first time that we would expect the number of daily dead less than 100 every day is starting the 8th of October. That is the green statistics, and this statistics is based on the 1st of July as the lockdown withdrawal date, which has actually happened even technically speaking a bit earlier than that. So even with that, the statistics are green. So in other words, all sorts of impositions, all sorts of restrictions, travel restrictions and everything, and I don't really know how that is supposed to be sustained. In principle, we would benefit if that was possible to be continued until literally the end of September. That is really what, until the first week of October, and this is what I am looking at. So if we sort of agree that less than 100 a day in terms of the number of deaths for such a huge country is quite well acceptable, then the infection regime is supposed to continue, including the second peak relapse, until the 7th of October 2020. This is the green reality. And I'm opening myself, as I mentioned, to reality. So going forward, what are we supposed to be expecting from here? We expect a relapse predicted from our model as the second peak. This is not just for India, for all the different countries. Eventual herd immunity, the time scale, well, I have given you a rough range of the time scale. For India, the time scale will be like starting the second week of October. What we have not considered in our model yet, and these are the limitations, so the model can be improved. Age and groups exposed to the I groups will have different rates of infection and mortality. So we have not explicitly considered them. The impact of migration, we haven't considered this in this particular model. We need to, and we would, and we should. The impact of phase lockdown versus the secondary relapse. I haven't gone into this at all. Phase lockdown would mean you sort of, there are many different structures, but one of the very standard structures is you do what is called like the containment zones, something like what is being followed in India at the moment. So you choose your zone 1, lock it for a certain time, and then you move that lockdown onto a different zone. This is not, I think, what's being done explicitly, but this is what should have been done if we did a proper phase lockdown. So how would that actually impact in bringing the mortality rate down is something that we need to predict, and we haven't yet. Vaccines and therapeutics research ongoing, and this is the part 3 that I said I potentially could talk about. And before I do, I just wanted to congratulate, thank, and extend my gratitude to the people who have been hugely instrumental in this particular paper, the paper which is communicated, and 2 follow-ups. So Shujit was an IIS, Shujit and Bidisha were IIS students, that's a husband-wife team, Indian Institute of Science students. Shujit is presently doing a postdoc here, and we worked together during his PhD, and the work was on a very different topic, on astrophysics actually. Debojyotida is from the Delhi University, one of my very old acquaintances. I had a brief sojourn at Delhi University when I returned back from the UK. Eva is my PhD student. She has what is called a very prestigious Krebs Research Scholarship, and she's working with me on basically mostly the part that relates to part 3, which is the drug prediction part and the research publications. The first one submitted, the one that I actually apologize for because I couldn't actually put that up on the archives. The second one is well, more than halfway through. I've got sort of a part draft of that, and we're working on this. Quite a few more to follow. And just at this point, before I proceed any further, because the next part potentially is part 3, and before I go or do anything with part 3, I just wanted to stop for a second and opinion regarding whether I should actually continue with part 3 or should just stop and start taking questions and sort of interlude part 3 within the questionnaire session.